All right. Thing was doing something weird, so start over again. Conic sections. Four major types that we're talking about: circles, parabolas, ellipses, which are like stretched out circles, and hyperbolas. Did I say parabola? Parabola, hyperbola. Circles, you're going to have x minus h squared plus y minus k squared equals some number squared. So the difference being that you're not going to have any numbers under the x squared and y squared terms. And if you did, they would be the same. So that's kind of a measure of where it stretches. If the x number is bigger, then it stretches more horizontally. If the number underneath the y squared term is bigger, it stretches more vertically. If they're the same, it stretches equally, which makes it into a circle. Ellipses, they stick together. That's the plus sign in between the terms. Hyperbolas have the minus sign. If you remember, there's two different kinds of hyperbola equations where you got a horizontal transverse axis. So that means it opens left and right if the x squared terms comes first, and then opens up and down if the y squared term comes first. So let's look at this over here. We've got a plus sign in the middle here, which means we're dealing with an ellipse. And so the equation, this and this give us the center. So the center is at -3, +1. It's the opposite of both of those. All right. Now, the numbers underneath here tell us the vertices and the co-vertices. So from the center point, we will go left and right by not 10, but the square root of 10. And the square root of 10 is a little more than 3. Square root of 10, 3.16. So I'm going to go 1, 2, 3, and a little bit more. And 1, 2, 3, and a little bit more. These are the co-vertices. And the way I know that is because that's the shorter side. Because the other one is the square root of 35. So notice this goes with the y variable. So that's up and down. The square root of 35 is almost 6, but not quite 6. So it's about right there. And about right there. Not all too important to get that perfect. But our ellipse is going to look something like this. Wow, I think that's one of the better ones I've done with this thing. Anywho, so that's our vertices and co-vertices. I do not want to search. Now we're supposed to find the length of the major axis and the length of the minor axis. So here's your minor axis. It's just 2 times a, so it's 2 square root of 10. And this major axis is 2 times b, so it's 2 square root of 35. Not too difficult. Oh, there we go. Kept missing this word. Okay, foci. We want to find the focal points. Okay, so those are somewhere here and here, but where exactly are they? The focal length is equal to, well, yeah, okay, it's the square root of b squared minus a squared. So it's just 35 minus 10 square rooted gives you the focal length. So the focal length is 5. So 5 away from the center. 1, 2, 3, 4, 5. There's one focal point. 2, 3, 4, 5. There's the other focal point. And that's really all we need to know. Oh, eccentricity. The eccentricity, you just take that focal length of 5 and you divide it by the length of a or b, the bigger number here, which is the square root of 35. And we could rationalize that, but 5 divided by square root of 35 is 0.845. So remember, the closer that is to 1, the more stretched out or oval-like ellipse like that ellipse is. All right, let's try a hyperbola. Let's been a while, hasn't it? So you see the y comes first. There's a minus sign in here, which is how we know it's a hyperbola. And so it should open like this because the y has come first. So let's do the coordinates. We've got x equals 0. The y is -2. So that would be the center. From there, we're going to use these numbers. So we got the, square root of 4 is 2. That's the length from here. We're going to go up 2, and that's not a point yet. Well, that is a point, but, and then this one, the square root of 25 is 5. So we're going to go 1, 2, 3, 4, 5. We're going to go 1, 2, 3, 4, 5. And if you remember, this is going to create a little box for us. What does that little box do for us? If we connect the corners through the center, these are going to be our asymptotes for our hyperbola. So the first, the vertices do go here. Hey, purple. They do go here and here. Okay. And they're going to open like this. That was a bad line. They're going to be something like that. And we can live with this as our opening, or as our graph of the hyperbola. Alrighty. Now, that was a little Kermit the Frog kind of action. Okay. Here's where it gets a little difficult because we're going to have to complete some squares to find the equations for these hyperbolas or ellipses or circles or whatever they may be. So I'm actually going to start with number 44 because it's kind of easy. Notice I've got an x squared, but I don't have a y squared. If I try to solve for y, I can just add x squared to both sides. I can subtract 4x from both sides. I can add 2 to both sides. And I get y equals x squared minus 4x plus 2. Oh dear. Oh dear. This is a parabola. Parabola. So, because the only one of those things was squared, the x was squared, then I know this is a parabola. If the x was not squared and the y was, it would be a sideways opening parabola. But as it is, we can take this x squared minus, oh come on, 4x plus 2. I'm going to set it equal to 0, and I'm going to complete this square. Move the 2 to the other side. I'm going to split this up. What's half of -4? It's -2. And then -2 squared is 4. So I have to add 4 to this side. -2 equals x minus 2 squared. Subtract 2 from both sides. X minus 2 squared minus 2 equals 0, or y. So right 2, down 2. That's the vertex of my parabola here. And it opens upwards. It's going to look something like that. Okay, just want to do that one real quick. Ooh, that was a bad line. This one, we're not so fortunate. We're not unfortunate, but we're not as fortunate because we've got x and y squared. So first thing we want to do is move our constant term to the other side. So there's a -7 on this side. On the other side, I'm going to take everything that has an x in it, and I'm going to move it over here. And I'm going to complete me a square. And I'm going to take everything that has a y over here and complete me a square. So y squared equals 0. This one is already done. There is no vertical shift, but there is a horizontal shift. We got x minus 4, half of that 8. And then -4 squared is 16, so we're going to add 16 to both sides. So what do we do? What do we get here? We've got x minus 4 squared plus y squared equals -7 plus 16. So x minus 4 squared plus y squared equals 9. So, so this one, if we were to divide by 9 on both sides, then both of our x and y would have the same number under them, which means this is a circle. Okay. So the x is a shift 4 and the y doesn't shift at all. So there's the center of my circle. The square root of 9 is the radius, which is 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Circles are very nice. Whoa. Not my best circle ever, but it is a circle. And now let's answer number 45 and we'll be done with this video. Okay. Same kind of situation. We're going to add 32 over to the other side. And we're going to split up the x's to -16x squared minus 32x. And the y's, we've just got y squared again. So we won't add anything there. And don't forget we've got this 32 here. So I'm going to take the -16 and I'm going to factor it out. And then I'm going to complete the square, same as usual. What's half of 2? It's 1 squared equals 0. But I need to do something to this side. So if I do this, I've got 1 squared is 1, but it's multiplied by -16. So I've got an extra -16 on this side that I didn't have before, which means I need to subtract 16 from this side. If you don't believe me, if we were to multiply x plus 1 times x plus 1, we would get x squared plus 2x plus 1 all times -16, which would be -16x squared minus 32x minus 16. See, there's a -16 that pops up when I go from this line to this line. I increase the left side by, or decrease it by 16. So I have to do the same thing to the right side as well. So what is that going to end up looking like? I will switch to blue. It's going to look like this. It's going to look like -16 x plus 1 squared plus y squared equals 32 minus 16, or just 16. And now I'm going to divide by 16 everywhere, because I'm going to get rid of that coefficient. And I'm going to end up with negative x plus 1 squared plus y squared over 16 equals 1. And we don't like to start these things with negative signs. So I'm going to switch it around to be y squared over 16 minus x plus 1 squared equals 1. And it's a hyperbola that opens up like this. See, these say hyperbola. These do not. However, both of our equations are wrong. So as long as we did this right, which I feel pretty good about, then we are correct. It's a hyperbola. None of those are the correct thing. So it's 45A. Let's have ourselves a scroll. Boom. Okay. We will pick back up with the fun on number 46 in the next video.